Hello everyone. So let's get into Python week number 2 by Akshat. So what's the agenda for today? So we're first going to learn about arithmetic operators, which you probably learned in math class. Then we're going to learn about assignment operators, then if-else statements, which are basically what we call conditional statements, and then finally logical operators. So let's get into it. So the first thing we have today is arithmetic operators. So these are your standard multiplication, division, subtraction, and addition, and you probably use that in your math class on a day-to-day basis. So similarly in coding, we use this to change the values of integers, such as 6 plus 4, 7 divided by 1, 2 minus 1, or 6 times 2. However, a key thing to note is that the syntax for all of these symbols is a bit different in programming. So for addition, it's still the standard plus sign. However, if you want to divide two numbers, you have to use a slash rather than the division sign. Then for subtraction, we still have our standard minus sign. And then for multiplication, rather than having an X, we use the number times, in this case, it would be an asterisk, times 2. So you'd get 12. So the last arithmetic operator, which you probably haven't done in math class, would be the modulus. The modulus is basically when you divide two numbers and the output that you get is the remainder. So let's take an example on the screen. It says 7% 4. So basically what this means is that the computer will do 7 divided by 4. If you guys can do the math, you'll get the remainder of 3, and as a result, we get the output 3. So we can also store expressions into variables. So right now, you're going to see these examples such as 2 plus 8, 4 times 4, and you might be like, why should we do this multiplication when we already know our final answer is going to be 16, or 10, or 7, or 4? However, in many situations, we have to divide two variables with each other, or multiply them, or add them together. As a result, we probably won't know what these numbers are storing inside and are going to need to divide them and store them into a new variable, in this case var. As a result, we can complete expressional statements while also assigning a value to a new variable. Now, I've been talking a lot about variables, but why do you think we need them? So the reason we need variables is so that we can reuse the same value that's stored inside of this one variable, and it's much more convenient for other people to read your code, but also it looks nice formattedly. Let's think about it. Imagine we have a long string such as, I want to go to Great America, blah, 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 and you list out your reasons. Would it make sense to keep on writing out this whole long string when you could just store it inside of a small variable such as var and then call it whenever necessary? As a result, it's much more efficient, but also makes it so that you don't have too much repetition and keeps it organized. So now let's do some practice. Using division, we have to calculate for a population density. So the first step is we have to get inputs for the population of the city and the land area in the city. So we have to ask the user for those two variables, and then we have to print the population density as a formatted string. So the equation that is given to us is that population density is equal to the population divided by the land area. So let's get into it. Alright, so now let's get into our situation where we have to calculate the population density. So if you guys remember from the previous lecture, from my previous video, which I highly recommend that you guys watch before this, we have to get an input from the user. So first let's think what a population would be. What type of data type is it? So usually when I think of population, I think of 7 million people, 8 million people, and those are all numbers. Therefore, I'm going to make this an integer, and inside I'm going to call my inbuilt Python library, and going to ask the question, enter population. Perfect. Now we have land area. So let's think. 5 million kilometers squared, 2,500 square feet. All of these are numbers, right? So that also will be an integer. So integer, Python's inbuilt library, and then enter land area. Perfect. So now what we have to do is store all of this into a new variable called population density. So now we've already been given this equation where population density is equal to population divided by land area. So basically what we have to do is population divided by land area, and that should be stored inside of our population density variable. So now all we have to do is print our formatted string where we have to write the population density is, and if you remember how we call a variable is braces, and then inside of the braces we put the variable name. So let's test it out for a small number right now. So let's say 20 and then 4. As you can see, we get the population density is 5. Now let's do a much higher number, such as that divided by 23.5, say whatever that is. And as you can see, we get a population density of 42 people per land area. And that's how you do it. All right, so now let's talk about assignment operators. So in your math class, you must also use expressions such as less than, greater than, or equal to. These symbols are similarly used in coding for conditional statements that we'll learn right now to compare two variables. They can also run certain pieces of code if they fall under the given condition. So now, let's introduce if-else statements. So if-else statements are basically conditional statements and are one of the pillars for coding, which consists of if-else. So the syntax for these statements are as given. So we first declare a variable name as var is equal to the integer 23. Then we run the syntax if, and then we write our condition, colon, and then the line after that we have to indent, and whatever we want to run has to be given there. So let's analyze this one by one. So we first got the if, then our condition, then a colon, and then we indent this so that it's falling under the if-else, and then it prints whatever is given. So in this case, we have var equal to 23. Is 23 greater than 46? No. As a result, it would not meet this condition, and it would go to the else statement where it would print var is less than 46. And that's obviously true. So now, how about you try to do this one? Okay. All right. So the first thing we have to do is understand that what do two equal signs mean? So as you know, we declare a variable name with one equal sign. As a way where we don't get confused about these two different equal signs, what we have done is if we want to compare two values, we have to use double equal. However, if you want to declare a value for a variable, we just have to use one equal sign. As a result, we have var equal 46, and we're checking is 46 equal to 46. Obviously, that is true, and it would print the value. The value is equal to 46. Now, let's talk about what if we want to check if two values are not equal to each other. If we wanted to check that out, what we would do is, rather than having two equal signs, the first one would become an exclamation mark. So we would do is 46 not equal to 46. Obviously, that's not true, so it would not meet that condition, and it would resort to the else statement where it would print var is equal to 46. Now, let's do some practice. Let's make a program that tells you whether the input is less than, greater than, or equal to 50. Please pause the video right now and try to figure it out. Alright, so now let's run the code where we have to get an input from the user and check whether it's less than, greater than, or equal to 50. So first we have to get an input of a number, meaning an integer, from the user. So we'll take this as number equals int, which is the data type, then our built-in library input, and then the question, enter number. Perfect. Now we have to do something with this number variable, right? So the first thing we do is write our syntax out for if-else conditional statements, which would be if, and then number greater than 50, and then colon. And now what we want to do is print number is greater than 50. All right, now let's do elif. So if it's not that, is number less than 50? If it is, then we want to do print number is less than 50. And then finally, we'll just have an else condition where we'll print number is equal to 50. So go through this section again and make sure that you got it, right? So let's test it out first. So enter number, let's do 12. We get numbers less than 50 because it is less than 50. Now let's do 50. We get number is equal to 50. Now let's do 67 and we get number is greater than 50. And that's how you would approach it. So now we've gotten a basic sense of what are if-else conditions, right? So now imagine we want to check two conditions at the same time, such as x is less than 5, but it also has to be less than 10. So this is where logical operators come in handy. They make if-else statements much more complex, and we can use additional operators such as and, or, and not. So let's see what the first one does. So for the and one, it has to meet both conditions. For or, it only has to meet one of the conditions. And then for the not, it can't meet either one of those conditions. So now let's do some practice with this. So let's say we're willing to go to In-N-Out in either San Jose or San Francisco. Now let's ask the user what city they recommend that has In-N-Out. And then we're going to check whether this city is in San Jose or San Francisco. If it isn't, we have to tell the user. So pause the video right now and try to figure it out. Good luck. Okay, so now we have to get an input from the user of a city. A city would be Los Angeles, Santa Barbara, and all of these are strings. So what we have to do the data type is str. And inside we put our inbuilt function and enter the question, enter city. All right. So now what we have to do is run if condition. If city equals San Jose, and this will right now just be pseudocode, or city is equal to San Francisco. And as long as it meets one of these conditions, it should print the result city meets the condition, let's say. And if it's not, which would be our else, we'll say print city does not meet the condition. All right, so now we have to probably use the or operator as we need it to meet either one of these conditions, right? So we'd use or, and let's fix this, space or. So city can either be equal to San Jose or city can be equal to San Francisco, right? We have to compare the two values and make sure they're equal. So let's test this out. Okay, enter city. Let's say we do Los Angeles. City does not meet the condition, which makes sense. Now let's try San Jose. And as you can see, the city meets the condition. So that's how you'd approach this problem, and try this out with some others. All right, now let's do the final assignment. So we have to get a given input from the user about a year, such as 2020, 2021, 2014, and we have to figure out if it's a leap year. So pause the video and try to figure out what conditions you'd have to check to solve this issue. All right, so now we have a year and we have to get an input from the user, which would be an integer. The reason it's an integer is it's going to be a year, such as 2014, 1988, and all of those are numbers. So we use integer, then our built-in Python library, and the question we want to ask the user, enter year. So now, we have to consider what are the characteristics of a leap year. So one characteristic is that it means that there's going to be an extra day in the year. However, another special thing about it is that it comes once every 4 years. Meaning, it comes every 4 years is we could use the modulus operator, meaning if year %4, which is, it basically gets you the remainder. If you divide the year by 4, it gets you the remainder, and if that's equal to 0, then it's a leap year. So we would print this year is a leap year. And then if it's not a leap year, if it doesn't meet that condition, we would print this year is not a leap year. So let's look at our most recent leap year, which was 2020. So let's see if that's a leap year. As you can see, it meets the condition and we get the value this year is a leap year. Now let's do 2022, which we know isn't a leap year. And as you can see, this year is not a leap year. And that's how you'd approach this. Now I'd highly recommend that you guys rewatch this video and also make sure to like and subscribe for the next ones. Hope you enjoyed.